Okay, so when Texas needs to think about adding future classes, it's always nice to get input from everyone on what we should add. Suppose we took a random sample of students and teachers and asked, what should the next AP class be? So here's our data from teachers and students. Notice it's in percentages, so you don't have raw counts of how many they talked to, but it did tell you 80% of teachers thought AP data was important. And I think that would really be AP stats, but whatever. AP lunch and AP Latin are my other choices. So you can see how teachers voted, you can see how students voted. So the first thing you're going to do here is to create the student bar chart below. Notice it's blank. Notice also that y-axis is in percentages. So is your data in your chart, right? So it should be pretty simple to complete. We're just going to fill it in for students. So we draw a bar to 30% for AP data. We'll color the teachers blue too for data. Lunch was 60%, no surprise there. And then Latin, 10. Oops, I forgot to do that, didn't I? Alrighty, good with that? Number 2 says complete the third graph by taking each bar from the student sample and stacking them, because that's essentially what's happened here with the teachers, because it was 80% data, so they took the data bar, put that one first, then they did lunch, stacked it on top, and they stacked Latin on top, and it all added up to 100%, right? Because it accounts for 100% of the teachers' votes. So now we're going to do the same thing with the students' votes. Right? So their bar will be Can we handle that? Not too bad, right? Okay, so according to the display, which AP class appears to have the most support?
AP data.
Data does, doesn't it? It does. Of course it does, right? Of course it does. AP data? Why? How would you explain your answer?
That's 110% of 200.
The combined, yep, results of students and teachers is greater the other options. Combined results of the students and teachers is greater than the other options. You can word it differently. Not one way to word it. Okay, but upon hearing these results, students were mad. They're like, hold up. They argued that the decision was incorrect because only 100 teachers were surveyed and 500 students had been surveyed. Use this information to fill in the table below with the number of student responses. Okay, so they already did AP lunch. And we know this because we know our percentages. With teachers, it was 100, and 10% of the teachers chose lunch, so that would be 10 teachers, right? So what number of teachers out of the 100 chose data?
80.
80, because 80% of 100 is 80, right? So 80. And then how many teachers chose Latin? 10. Easy enough, right? Now students, there's 500 students. So where did they get the 300? Well, 60% of 300, or 60% of 500 is 300, right? So in the AP data, 30% of 500, what's that?
150.
Good, 150. All right, and how many does that leave for Latin? 50. 10% of 500 is 50, indeed. So there it is. Now, how many times more students were sampled than teachers? 5. 500 versus 100, right? So 5. How can you update the third graph and number 2 to account for this sample? Like this guy right here. How can we adjust this graph to show that this is really 5 times the people in 5 times the number of responses than this one was? What could we do to that? Okay, you could make the teacher a fifth of the size, or you could make the students 5 times the size, right? Same effect. So if we do that, we make it 5 times the size. That means I'm going to do the student one and stretch it out. Obviously, we're going to run out of space, but 5 times the size. I'm going to pretend like this is 2, 3, 4. Don't judge my lines, 2. I can smell you doing it. Stop it. All right. But then I can shade it, right? And this is a better reflection of the results, wouldn't you say? Don't be judgy. All right.
Isn't that 6?
Yeah, it is. All right, I'll fix it. I don't know what to talk about. Kirby. Hey, it's 5. It's 5. It's fine. 1, 2, 3, 4, 5. Okay? So what we've created here is what they call a mosaic plot. It's a segmented bar graph on steroids because it tells us a little bit more about the data set than just percentages. You get a better idea of the proportion of respondents. Okay. Now, based on this guy, our new graph, what would you say the new AP course should be? Okay, and how would you defend your answer? The bar what? I heard the bar something. The area shaded in AP lunch, whatever color you chose, is much bigger than the areas of the graph that are shaded the others, right? So you're looking at total area to make your decision here. So area would be AP lunch. And would say the total area for AP lunch greater in the mosaic. Let's see if I can do this. Plot. The areas for data or Latin. Okay? Not too taxing yet, is it? You okay? All right. Can I turn the page? Okay, you will find that the summary on the top of the page is pretty similar to what we did yesterday because we haven't really added that much new material. All right, so let's see if you remember this. The displays for categorical data. Which display has each bar that represents a frequency or a relative frequency? What's the name of that display? It has bars. Bar graph, bar chart, however you want to say it is fine. Okay, what kind of display stacks up the bars to make a total of 100%? Good, you remember that? Cannot write small enough to fit the blanks. Oh. And then today's, here's the new one. It's called a mosaic plot. And the big difference here is that the width of the bar is proportional to the actual group size. That's the big change here, all right? The width of the bar is proportional to the group size. I do put highlighters in your caddies for you, but you don't have to use them, but if you like to, you can. All right, now, the association piece that we talked about yesterday. How do you look at these and know if there's an association? Well, if the striping's different, right? So we would say here, if knowing the value of a variable helps predict the other value, oops, not the highlighter, predict the other value, that is what we mean by association. One helps predict the other. There's some kind of relationship. And the segmented bar graphs are different if there is an association. Little summary of what we just did yesterday. Everything okay?
Yeah.
Go make it.
I just remember.
All right, let's try. I want you to try this one down here. The following table gives the result of a random sample of upper level students at Rocky Vista University, the Fighting Prairie Dogs, along with a mosaic plot. So, read your data, see if you can do A, B, and C. And we will come back together in a moment and check your work. If you get stumped, you have a neighbor. Ask your neighbor. If you're still stumped, then we can talk. I bet you can figure it out. And I'll show my answers here in a second, okay? All right, so the first one is asking us to look at junior data only. So currently working, I just abbreviated CW. 14 out of 51 gave me 27.5%. Not working but had a job, 22 out of 51, which was 43.1%. Never had a job, 15 out of 51, that's only 29%. And then I do the same thing with seniors. So then it says, did we do okay with that? Yeah? Okay. Write a few sentences summarizing what the display reveals about the association. There is an association for sure between class and job experience. And then I give some numerical defense to my answer. For example, 37.5% of seniors are currently working, but only 27.5% of juniors. Your evidence could be different, right? A lot of possible, why are you doing that? A lot of possible valid pieces of evidence you could use to defend your answer. So, but what I did want to point out is that when you do these, you have to have context in your answer. My context was right here, between class and job experience. The nice thing is you don't have to repeat that every sentence you write. As long as it's somewhere in your answer, you get the points for context. But every question I've graded, if you don't have context, they automatically dock a point. So I will train you early and a lot to do this. All right, questions for me? No? Got it? All right.